Last topic here, composition of functions, but in terms of inverses. So what occurs when you compose inverse functions? Well, the answer is pretty simple, actually. Consider what occurs with a mapping illustration. So let's think about this for a second. Here is a map. So there's a domain, and I'm going to call the things on this domain X. Then you have over here your range, and we call the things here Y. And then to take anything from here to here, you just hop on the F train and you wind up here in the range. But if you want to go back to where you started from, you hop on the inverse train to go back. So that's how the whole process works. So now what happens if you compose? Well, what does that mean? Well, let's look at this thing. Suppose I'm looking at F inverse of F of X. Okay. So what happens here? Well, it says that first I'm starting out with F, and then F jumps on the F train, comes over here. So what happens is that F of X becomes Y. And then what happens? Well, Y jumps back on the F inverse train. So now it jumps back on the inverse train and it's back to where it started from. Oh, that's cute. Well, what happens if it works the other way around? What's F inverse of, no, I did that already. F of F inverse of Y. So, okay, so now I'm starting here in the range, or what is the range? Again, remember, domain and range are interchangeable. We just define this now as a domain for the inverse operation, and this is the range for the inverse operation. So we switch what we call each one. Okay, so make sure that's understood. So now F inverse takes the y's and the positives here in F land. Now we get on the F train, and what does the F train do? It takes you right back to where you started from, which is the y. So it looks like if I compose, notice each time, whatever I started out with, that's how I end. If I start with y, I end with y. If I start with x, I end with x. Theorem, if the functions f and g of x are inverse functions of each other, then if I compose one with the other one, g of x inside of f, what do I get? Well, I get the same thing. Whatever this is, whatever I start out with, that's what I wind up with. If I compose the other way, whatever I start out with, that's what I get back out. Again, and using the function inverse notation, again, noticing I'm using this idea here, which I'm gonna like more, but really look at it this way, look more this way. But you see that it's the same thing, but you do get, as we mentioned, F inverse of y composed with F gets you Y. F inverse of F composed with X gives you X. Okay, so given that, let's look at this example. Yay! Given F of 5 equals 7, what is F inverse of 7? So, okay, F inverse of 7. Well, it just should give me, since F inverse is the inverse of F, 5 goes to 7, so 7 goes to 5. Okay, again, just following this mapping idea. I started with a 5, it brought me to a 7. So 7 must go back to 5 if I jump on the inverse train. What is F inverse of F of 5? Well, I don't need, again, perfect. It should be 5. F of 5 takes me somewhere. Okay, I'm going to illustrate it this way. What does it take you to? By the way, if you're taking Math 112, you actually need to do this. There's a little tricky part to this, and you must do exactly what I'm doing here. And then to add something else to it. But F5 takes me, let's say, to 8. So what does F inverse take me to? Well, F inverse takes me back to 5 again, right? And even if I compose it the other way, what is F of F inverse of 8? Again, just to illustrate a journey, F inverse of 8 takes me somewhere. And now where does F of A go? Well, should take you right back to where you came from. So it goes through 8. Great. Are the functions f of x equals 4 over x plus 4 and g over x blah, 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 inverse functions? Compose two functions, determine if they are. Okay, so remember, if they are inverses of each other, when I compose them, what should I get? All right, well, it says that I should just get this. And notice they're both x's, so that's where this expression comes from, or this writing it this way instead of writing it the other way. So I'm going to just say, look, f of g of x, what does that give me? So here's f of x. So again, notice the way I'm writing this. Look very careful. I'm going to write big old parentheses where the x used to be, plus 4. Then I'm going to dump in g of x. G of x is this mess right here. So I dump it inside. And that looks kind of scary. So what can I do here? Well, let's clean this up a little bit. I think what I'm going to do is multiply top and bottom by x. There's several ways of doing this. I'm just going to decide to do it that way. So I'm going to and see what happens. Okay, so I said I'm going to multiply top and bottom by x. I am going to do that. Of course, this bottom consists of two terms, so I have to distribute through. The numerator doesn't look that way. 4x, that works. 4 times x is 4x. But here I'm going to distribute. So when I distribute x times this entire expression, remember the x's cancel, so leaving me with 4 minus 4x. And here, when I distribute x times 4, I get 4x. Now, these negative 4x and 4x add up to 0. And here I can divide 4 divided by 4 is 1. Ah, look, I got the x back out. Hey, what would happen if I reverse it the other way? Let's find out. Oh, I'm having so much fun. Now I'm going to write g. Well, g is this thing. But wherever I see a variable, in parentheses, I see variables in 2 different places. So everywhere I see variables, I'm now going to replace with big old parentheses. Why? Because I'm going to enter, instead of the variable x, I'm going to enter the function f of x. So I'm going to enter a function here, but what is the function of x? It's this mess over here, and now you're shaking on your boots because, oh boy, look at this. This is a disaster. No worries. Something I'm sure wonderful is about to happen here. I'll just multiply it. I'm not going to distribute anything. Again, there's 4 sitting in the numerator. So I'm just going to go 4 times 4 here, okay, just to make it look a little nicer. So 4 times 4 is 16. I still have this mess here. Let's see, which way do I want to tackle this? I could do what I did here, find the common denominator, which was x here, and multiply top and bottom by this. That will work, just like I did here, but I would do it by x plus 4, x plus 4. I'm going to take a slightly different route just to give you something new to look at. Remember, this says this entire expression divided by this entire expression. Remember, when you divide, let me come over here. Oh, I'm not even showing things. Oh my God, I've been recording and not showing. Sorry about that. So take a second, stop. That's what I did earlier. I'm sorry. Should be looking over here. I didn't push the piece of paper high enough. Oh well. So again, I multiply top and bottom by x, and that gave me 4x here. Distributed the x, and I get x times this first term. I get 4 minus 4x. Y times x gives you, 4 times x gives you 4x. Then these add up to nothing. give me 4 divided by 4x, and that gives me the x. So I could do something like that here. Multiply top and bottom by x plus 4. But I'm not going to do that because what I'm going to do is, remember, if I say something like this, 5 divided by, in fact, let me put it this way. If I say 5 divided by 3/4, if you remember from arithmetic, what you should do is change this to multiplication and then multiply by the reciprocal. So that gives you, then multiply 20/3. Well, that's the thing I'm going to write here. I have this expression. I'm now going to divide by this other one, but instead of dividing, I'm going to multiply by the reciprocal of this, which is x plus 4 divided by 4. And that is going to help me out. Why? Because I'm going to distribute this fraction, x plus 4 over 4 times 4. So I'm going to write it out so you'll make sure you're not confused of how I get things. So I write that, and then minus, then I'm going to multiply here times the other expression. Great. And 16x plus 4, just like that. So immediately I see that these two 4s, 4 divided by 4 is 1, so I'm left with x plus 4 here. Minus. All right, so I got that x plus 4 and x plus 4 again are 1, cancel, whatever you want to think about it. 16 divided by 4 is 4. 4 minus 4 is 0, and I get x. So no matter how I compose, I'm going to get x back out, and that's what it says. If that's must mean that f of x and g of x are inverse functions. Why? Because this came true. I composed f with g, got x. I composed g with f, got x. So they're inverses of each other. So that only happens if the functions are inverses of each other. So I'll leave you that, and you can pause the video here, take a look at this, and hopefully this has helped.